All right, let's see. Again, nothing specific tonight, right?
No, not really. I have spring break next week, so.
What's that? Oh, yeah, I know. Well, let's go over the second half of this chapter. Last time we did 7.1 through 7.4 quiz, and we talked about how to do that stuff. Let's look at 7.5 through 7.9. Now, I'm not sure how much of this stuff you've had. Doesn't really matter if you've had it. I don't mind teaching it to you for the first time. If you haven't had it, you'll be getting it very first thing when you get back. So if nothing else, we'll get you a little ahead of the game. But have you gone all the way through chapter 7?
I don't think so. We're like doing like factoring, like quadratics or whatever right now.
Okay, well, this is factoring.
Okay.
However, the first thing we want to look for whenever we factor a polynomial is to see if we can pull a greatest common factor out. Is there any term that I can divide each of these into evenly?
D?
Yes. So I can factor D out. What am I left with when I divide D squared by D?
3D.
3D, and over here?
11.
So that's how you do it.
Okay.
So greatest common factor means greatest. In other words, had this been 12, I would have factored a 3D out because I could, leaving behind that. So you always want to factor the greatest thing that you can out when you're factoring a greatest common factor.
Okay.
So how about this one?
Z.
Well, that's the letter that's the greatest common factor, but there's a number also.
Oh yeah. So would it be 2?
Does 2 go into 9?
9Z minus 2.
Okay. That's what you were trying to say?
Yeah.
All right. Okay, now this is a more traditional quadratic. By that, I mean it has an x squared term, it has an x term, and it has a number. This is the quadratic that you always solve. If it's an equation, you always want to have it set equal to 0. In this case, it's not actually an equation, it's just an expression that they've asked us to factor.
Okay.
So where do I begin?
Put an X in each of the parentheses.
Next step?
And then I think it's plus and plus.
Good. Next step.
And then I think I forgot.
Okay, what do we need? We need factors of 20, which means two numbers that multiply to 20.
Okay.
That add, because of that plus sign, to this number.
Right.
What are they? What two numbers multiply to 20?
5 and 4.
Add to 9, yeah. And it doesn't matter if I put the 5 here and the 4 there or the reverse. Okay, you actually seem pretty good at these. I think. After we do one or two of them, I'll bet you got it down. Okay, what goes here?
So R in each of the parentheses. Minus and minus.
If I had minus and minus, when I multiply that last part of the foiling process, I'm going to get a plus.
Yeah.
So it can't be minus and minus.
So minus and plus?
Always. In other words, what this means is that the signs have to be opposite.
Okay.
Always. If that's plus, the signs have to be the same. If it's minus, they have to be opposite.
Oh, okay.
Now, what are we looking for? Factors of 18 that do what?
That add to make -3.
Not add, to subtract because of that, and not to -3, just to the number 3. So factors of 18 that subtract to the number 3, what are they? About 6 and 3.
Yeah, I think that works.
Yeah, they multiply to 18, and they subtract to the number 3. Now,
Yeah.
which one goes where?
I think the 3 goes first.
Yeah, the larger factor, the 6, goes with the sign that is in the middle term, which is negative. Has to be like that, because otherwise if I put the 6 over here, I'm going to get a net positive as a middle term. So that's the way to memorize it, is to just say whatever two factors accomplish what we're trying to accomplish, put the bigger of those factors with the sign of the middle term.
Okay.
All right. Now they get a little harder. Because the moment I stick that 2 in front of the x squared term, I can throw out all those rules.
Yeah.
You know, I can throw out the rules that the factors of that number have to add or subtract to the middle one. I can't say any of that anymore. So what goes here and here?
2x and then x.
Okay. And we still examine the sign. What does that mean?
The signs have to be the same.
And what are they going to both be?
Is it plus and plus?
No. In other words, when it's either minus minus or plus plus, again look to the middle term to tell you.
Okay, so minus.
Yeah, because we can't get a middle term of minus if we have plus plus.
Yeah.
Everything would be plus, and we would have a plus as a middle term. And now there's really not any choices, are there? There's only one set of factors for one. And does that work? Well, when I multiply the inside together, I get minus x. When I multiply the outsides together, I get minus 2x. That adds to minus 3x. We got it right. Okay. Okay. It's not hard when they only have one factor of that number, but the next one will be a little bit harder. In other words, as you increase the number of factors that you can have, well, it makes factoring it that much more difficult because you have lots of possibilities. Remember, we don't have any hard and fast rule anymore. So it's kind of trial and error. So what goes here and here?
3b and then b squared. No, and then just b.
Okay. What are my signs?
Minus and minus. And then
Factors of 4. What are they?
4 and 1.
Okay. What else?
2 and 2.
Okay. That's it.
Yeah.
Normally, I suggest to people that they always try the factors that are closest together. But we can see right away that's not going to work. In other words, if I put 2 and 2, there's no way I'm coming up with 13b. I get 6b and 2b. So I know 2 and 2 isn't going to work, which means it has to be 4 and 1. Where's the 4 need to go?
On the second parenthesis.
Yeah. now when I check it, I got minus b minus 12b. That gives me minus 13b. All right. Little different. What's different about it is it doesn't have an x term. What's unique about it is that it has its own name. It's called difference of squares. Some people even call it the difference of perfect squares.
Okay.
And the reason is that's exactly what it is. It's the difference of two things that are perfect squares. X squared is a perfect square and 9 is a perfect square. So whenever you recognize that you have the difference of two perfect squares, it always factors into x minus 3 times x plus 3. Or the square root of this minus the square root of that times the conjugate. In other words, changing the minus to a plus.
All right.
Okay? So the one that you really want to remember as being your general formula for the difference of perfect squares is this. A squared minus b squared. That has to be the difference of perfect squares. These are both perfect squares.
Yeah.
So that's always what?
A minus b, and then a minus b.
And a plus b.
Plus b.
Okay, it's always this way. And I would even suggest always putting the negative first. Even though it doesn't matter, you could reverse these around. It's the same thing. It's just consistency helps when you're trying to remember mathematics. By consistency, I mean doing the thing in the same way, even when you have multiple ways of doing it. Always try to do it the same way. So, if I had something like this, is that the difference of perfect squares?
Yeah.
What is A?
4x squared.
No, that's A squared, notice.
So is it just 4x?
No, what's the square root of that?
2.
2x,
2x.
right? 2x times 2x is equal to 4x squared.
Okay.
Okay? What is B?
Minus 16.
No, that's B squared.
Oh. So is it 4?
Uh-huh. And that's what you have to do whenever you're doing the difference of perfect squares, is you have to figure out what A is going to be and figure out what B is going to be. So when I factor this, how does it factor?
2x minus 4, and then 2x plus 4.
Uh-huh.
Alright.
And that's how you do it.
Okay.
Okay? So always look for that. That's a very, very common theme. Even when you take the ACT test 3 years from now, you're going to be seeing a lot of difference of squares, difference of perfect squares.
Okay.
Okay? Let's look at this one here. What are the signs?
Plus and plus.
And now we can say those statements. What do we need? Say what we need.
We need factors of 121 that add to make 22.
Perfect. And they don't have to add to plus 22. They have to add to that number, whatever that number is. Ignore the sign on Okay, so what is that? There aren't very many factors of 121. That's a strange looking number. Do you know what the factors of 121 are?
I think 11 times 11.
Perfect. And there's your answer. And that gives us that as a middle term. Notice that the only term I ever check is the middle term. It's because I don't need to check the others. I got my Z and Z from this, so I know it's correct. And I looked for factors of 121, so I know 11 and 11 are correct. The only term I ever need to check is that middle term. And that's the one that people miss the most. So if you're going to check your solution, that's the one you want to do, is this, what I call the double smiley face. Check the inside multiplication and the outside multiplication.
Alright.
And add them together. Okay, now we have some equations to solve. I like this chapter. This is a very healthy chapter to be reviewing because there's no possible way you don't know how, you're ever going to not know how to, you're going to need to know how to do these. Not everything you learn in algebra will you need to know how to do in the future, but this you do. At least you'll need to know how to do it for the next 4 years, and probably 8 years if you go to college.
Alright.
So this is an equation, not an expression, but we solve it the same way by factoring that quadratic.
So it's just M and M. And then minus and minus. And then 9 and 2, but the 9 is
Perfect. So now what?
and then you plus 9.
Well, first of all, let's make a leap. You might be doing it and just not expressing it, but because we have one thing multiplied by another thing equals 0, one of these has to be 0. And we're going to solve this equation by setting both of them equal to 0 and coming up with 2 solutions. So the first step really is m minus 9 equals 0, or m minus 2 equals 0. So this one yields a solution of what?
9.
This one yields a solution of 2. So we have m equals either 9 or 2. And if we plug those back in, they both work. When m is 9, this is 0. So this would always be 0. And when m is 2, this is 0. So this would always be 0.
Alright.
So solving the equation is really just taking one extra step. Here, let me get this a little higher up here. And okay, so now they're getting a little harder. We have w cubed minus 9w squared equals 0. Always check a couple of things as first things. Can you take a greatest common factor out of that? Or is it difference of perfect squares? Is it difference of perfect squares?
I don't, wait.
No, this is a perfect cube, but it's not a perfect square.
Yeah.
Nor this is actually, this is, the square root of this is 3w. So this part is a perfect square, but this one isn't. So it's not difference of squares. Can you factor a greatest common factor out?
Is it W? Wait.
Yep.
Yeah.
Leaving behind,
9W.
well, what's this first term? What's w cubed divided by w? In other words, when we factor something out, what we're really doing is dividing each term by that thing. So whatever goes here, yeah, In other words, that has to be W squared because when I redistribute, I got to get W cubed.
Alright, 9, is it just 9W?
It is. What does that tell me? That tells me I didn't factor out the greatest common factor. I factored out a factor, W was a factor, but it wasn't the biggest one because I still got another W I could take out of there. So let's go back and take a W squared out. You see why I can do that?
Yeah.
In other words, I want to take the greatest thing that divides evenly into both of those. W cubed would not. W cubed wouldn't divide evenly into W squared. But W squared does. And it leaves this behind. So, if all of that's equal to 0, what are my solutions?
Positive 9.
That's one of them.
And then, I don't know the other one.
Well, remember what I said, that when you have two things multiplied together that equal to 0, set either one of them equal to 0. Well, we set that one equal to 0 and got W equals 9. Well, now we need to set that equal to 0. What is
So
W?
W squared equals 0?
Yeah, which means W equals 0. Those are the two solutions.
Alright.
Notice that if we plug in 0, sure enough, 0 minus 0 is 0. So the 0 solution definitely works. And the 9 also does. This gives you 9 cubed. This basically gives you 9 cubed. All right. What goes here and here? Need factors of 6m squared.
So is it 6 and then m?
That's a possibility. It could be that.
Okay.
But again, there's multiple factors of 6. What's another factor of 6?
3 and 2.
Those are closer together. Let's try those first. Just because I've done enough of these that the answer usually lies in the factors that are close together. What's my signs?
Minus and minus.
There's only one factors for one. Does that work?
Yeah.
Yes, it does. Minus 2m minus 3m gives you minus 5m. Okay. All right. I get a little harder. What is this that we're looking at here?
I have no idea.
It's quadratic.
Oh.
Right? It's got an h squared term, it's got an h term, and it's got two numbers that we can combine to get one number.
Yeah.
How do we solve quadratics?
Factor.
First, we put everything on one side and 0 on the other. And the 0 is the really important part.
Okay.
We have to have 0 on the other side because that's the only way you can solve it when you get two things multiplied together equal something. If I have two things multiplied together that equal 3, I can't solve it. A whole bunch of combinations could equal a number. But when I say two things multiplied together equals 0, now I can solve it.
Yeah.
So let's put everything on the left side and 0 on the right. What do we have?
So let's minus 10.
Now let's start with the squared term. Let's make sure we leave it in quadratic format.
Yeah, so is it h squared minus 10?
Now, next comes the h term.
Oh. So plus 3h?
Now combine all the numbers and leave them on the left side.
So minus 18?
Uh-huh.
Right, and then equals 0.
Exactly.
Alright, so H and H, plus and minus, and then
Factors of 18 that do what?
that subtract to make 3.
Exactly. What are factors of 18 that subtract to 3?
Is it 6 and 3?
And where's the 6 go and where's the 3 go?
I think the 6 goes on the second one.
No, remember the bigger factor
Yeah.
goes with the sign of the middle term.
Okay, so it goes on the first one.
That's the only way we're going to get a positive, because that's got 6h and this has got minus 3h. So that's why the biggest factor has to go with the sign of the middle term. That's the only way you're going to get a plus sign in the middle term.
Okay.
Okay, so what is our solutions?
Minus 6 and positive 3.
Good. Okay. This problem, there is a couple of ways to do it. What would be probably the standard algebraic way to do it? Actually, I don't know. You tell me how you would do this, how you would solve this problem.
I have no idea.
Well, how about we start out by dividing both sides by 4.
Okay. So, yeah.
Okay. Now, how are we going to get s all by itself?
Square root it.
Perfect. Now, when you take the square root, when you're solving an equation by taking the square root of both sides, which is what we have to do, the first words out of your mouth, and don't ever forget this, are plus or minus. And the reason I beg you not to forget it is because 95% of my students forget it.
Okay.
It's one of the hardest things to remember. It's plus or minus, always, when I have to solve an equation by taking the square root of both sides. Okay? That's one way to do this problem. It's a quadratic, so even though it doesn't have an s term, what happens if I do this? Now what's it called? Difference
Of perfect squares.
Yeah, because this is a perfect square. What's the square root of that?
4. Or no, just s squared.
What's the square root of this?
4s.
Well, 4s times 4s would be 16s squared.
Oh, so 2s?
2s. What's the square root of 144? 12.
12. Yeah.
So what's the rest of it?
Then 2s minus 12. Or 2s plus 12, actually.
Okay.
Yeah.
Now solve both of those. What do you get for solutions? We got 2s minus 12 equals 0, or 2s plus 12 equals 0.
I think the first one is positive 6. And then the second one is negative 6.
Aha! Notice we got our plus and minus when we did it this way, and there was no way to make a mistake.
Yeah.
In other words, even if I didn't remember that you have to put a plus or minus in front, and if I did the problem this way, in other words, setting it up as a difference of perfect squares, I automatically get the plus minus. It forces me to. What's this called?
Is that the perfect squares?
No, it's not really. I mean, it looks like it could be, but for one thing, it's not the difference. The sum of perfect squares does not factor. If I have a squared plus b squared, that doesn't factor, believe it or not. So I'm always looking only for the difference of perfect squares. Even if that was a negative sign, this wouldn't be the difference of perfect squares because I got this 20k over there.
Okay.
I mean, I could factor the left side, but that doesn't help me solve it. This is a quadratic. Why? It has a squared term, it has the k term, and it has the constant. In other words, the other one, 13, is also a quadratic. So the only thing you really need to be a quadratic is you have to have a squared term. Then you have a quadratic, okay? This is a more traditional quadratic in that it has the k squared term, it has a k term, and it has a number. How do we solve those?
K and K.
No, not yet. First of all, we got to have 0 on one side and everything else on the other.
So k squared plus minus 20k plus 100.
Okay.
Equals 0.
Okay. That's the first step.
Yeah, and then k and k.
Yes.
And then minus.
Factors of 100 that add to 20. Right? That add to 20 because of that plus sign?
Yeah,
10 and
10 and 10.
Uh-huh. They multiply to 100 and they add to 20.
Alright.
So what's your answer?
10.
Just one answer for this quadratic.
Yeah.
Actually, it's one answer twice. And you'll get to a point in math where they talk about multiplicity of the answers. And this, you would say, has one solution with multiplicity of 2. Because there were actually 2 different answers. That one, k was equal to 10, and this one, k is equal to 10. But we won't get into that right now. All right, let's have a look here. That was good practice there. Let us look at, hold on. I saw something in here that I liked when I looked at it before. Oh, it was the, okay, we've done all of that. We've done all of that. We've taken the quiz. Let's look at the chapter test. All right. What's the degree of 1?
What?
The degree, it says identify the degree and classify the polynomial by the number of terms. So what is the degree on this one here?
What do you mean by degree?
It's asking you what is the highest exponent that you see?
Oh, 3.
Okay. How many terms are there?
2?
1, actually.
1.
This is considered 1. If they're multiplied together, it's considered 1. They're added and subtracted. In other words, there's 3 terms there. What is the degree of this one?
2.
And there's 3 terms. What is the degree of this one?
12, and there's 3 terms.
2 terms, right? Find the sum or difference. Let me bring up my... So we have minus 2p plus 4 minus p squared minus 6p plus 8. Do we need the parentheses on the left?
No.
No, you're right. You don't need them at all. It's a little clarifying to have them, but they don't accomplish anything. Do we need the parentheses on the right?
I think so, yeah.
Yeah, because we're subtracting. If this was a plus sign, then we wouldn't need them either. But because we're subtracting all three of these terms, we have to go in and apply this minus to each of these terms. So my next goal is to get rid of the parentheses. So what are my terms going to be?
P
Minus p squared.
minus P squared.
Now distribute this negative sign to the second term.
So is it just 6P
It's plus 6p.
plus 6P
Now distribute it to the constant.
minus 8?
Okay, that's good. Now simplify that and put it in correct order. In other words, put the highest degree term first, the next highest degree second, and the constant last.
Okay, so minus P squared plus 4P minus 4.
Okay, so that's all they asked us to do. So that's the answer. But let's do one other thing. Solve that equation. What would your first step be?
Minus P and P.
Actually, that makes it extremely hard to do. That's why I wanted to ask this question. We don't want to do that. We don't want to do that. That changes the rules of everything.
Alright.
You don't ever really want a negative in front of your squared term. You want it to be positive. So how can I change that to positive?
I don't know.
How about if we divide both sides of the equation by minus 1?
Okay.
What does the left side now become?
P squared plus minus 4P plus 4 equals 0.
Okay, now notice how much easier the problem is to solve. Now it looks very traditional and typical.
Yeah. So P and P minus and minus. 2 and 2.
Good. Yeah, you don't ever begin factoring if there's a negative term there.
Alright.
Always divide everything by minus 1. Let's see. Find the sum and difference. Okay, rather than have me rewrite this again, do we need the parentheses on the left?
No.
Do we need them on the right?
No.
Okay, so let's write what we've got. 4s squared plus 2st plus t. What's the rest of it?
Minus 3s squared plus 5st minus 4t.
Okay. Combine it. How many s squareds do we have in total?
Just 1.
Takes care of that one and that one. How many?
7.
Let's do the middle term first. Yeah, sorry. you were ahead of me. And now the last term. How many t's do we have?
-3.
Okay. Let's not talk about factoring that. They didn't ask us to factor it. They just asked us to add the two polynomials together.
Okay.
That's an advanced factoring problem that you're not quite ready for yet. Okay, let's find the product. H minus 5 times H minus 8.
So H squared. Then minus 8H. And then minus 5H. Minus 40. Oh, plus 40.
Plus 40. Remember, minus times minus is plus. Okay,
Yeah.
simplify.
H squared minus 13H plus 40.
Give me some conviction. You know this stuff. You're just not sure you know it.
Yeah.
And when you get to a point where you can have some conviction in your voice instead of questioning whether that's the right answer or not,
Yeah.
that's when you're going to be really good. I mean, you're getting there. You made a lot of improvement. I'm impressed. But the only thing I'd really like to see is confidence when you give me an answer.
All right.
Do you know what it is?
4W squared. Is it 10W? Plus
Conviction.
10W?
Conviction. Don't ask. Tell me.
Alright,
I know it sounds like a small thing, but it's an important thing.
minus 6W. Minus 15.
Simplify.
4W squared plus 4W minus 15.
Good. Okay, let's z plus 11 times z minus 11. Now,
Okay,
before you begin this, you can FOIL it if you want. But do you recognize what it looks like? It looks like a minus b times a plus b.
Yeah.
So that's the difference of perfect squares factored is what it is. So we know that this, when you multiply them together, gives you the difference of perfect squares. So does this. In other words, you can multiply it together a lot faster if you're familiar with difference of perfect squares. What does this have to be? Don't FOIL it.
0.
It's got to be z squared minus 121.
Okay.
In other words, this is a squared minus b squared. A is z, and b is 11. And because I knew I was looking at a minus, or a plus b times a minus b, I knew the answer had to be a squared minus b squared. Now, FOIL it and see what happens. Every time you FOIL one of these things, the middle terms cancel. That's why you don't have a middle term. So if I do it the hard way, I'm still going to come up with z squared minus 121, but I'm going to take 20 seconds longer than I would have otherwise. So all of these little tricks are helpful. Being able to recognize difference of perfect squares in a factored format is helpful. factor the polynomial.
Okay. You set it equal to 0?
No, it's just a polynomial. It's not an equation. But
Okay.
we're going to do the same thing that we would do if we did have it set equal to 0. In other words, if it was equal to 0, our solution would involve factoring it. Right?
Yeah.
Well, they don't want a solution. They just want to know how to factor that.
So 7 and then x. No, 7x and then x.
Okay, 7x and then parentheses x.
Yeah. Minus 3.
3.
3.
In other words, not 3. You know that 3 times 7 is 21.
Yeah.
Why is there hesitation there?
Because I wasn't sure if that was
I
correct.
know. You're going to get your confidence up before long, I guarantee it.
Alright.
Okay, n squared plus 7n plus 10. You can probably do these in your sleep.
And yeah. Plus and plus. 5 and 2. M and M, minus and plus, plus and minus, and then 12 and 2.
What do the two numbers need to do? They need to
They
multiply
need
to
to
24, but what else do they need to do?
Subtract to make 2.
Okay, does 12 and 2 work?
I don't think so, no.
12 and 2 definitely don't subtract to 2.
Yeah. Is it 6 and 4?
It is. Where's the 6 go?
The second one.
Good. That's plus 4m minus 6m gives you minus 2m. All right, what else we got here? I hate it when they use the letter G. I don't know why I hate it, I just do. I think it tends to get confused with the number 9. And even worse is a lot of times they'll put G and Q in the same equation of all the things. Which is really bad because they look the same.
Yeah.
Kinda. They look close enough together that it's real easy to get them confused if they're in the same equation. So what goes here and here?
6G and then G.
Okay, I don't know what the answer is yet, but I'd always like to see you start with the two closer factors.
So 3 and 2.
It may not be right, and if we can't solve it, we'll have to go back and try 6 and 1.
Yeah.
But let's give this a shot first.
Okay, so plus and plus.
Now remember, you can't use those rules. You can't say factors of 7 that add to 23.
Yeah.
They no longer apply when I've got coefficients in front here.
Yeah.
You're going to have to use a little bit of trial and error here. There's only one set of factors for 7. That's it.
Yeah.
So you can only put a 7 here and a 1 there, or a 1 here and a 7 there. So let's just try them. randomly. In other words, pick one and see if it works. Does that work?
No.
Does that work?
Yeah.
That's my California method.
Okay.
Okay? In other words, I don't use the California method. I don't even know if they've taught you the California method or if they teach that anymore.
I don't think so.
Yeah, I don't think so either, surprisingly. It's so complicated. It's harder to remember the California method than it is to do the factoring by trial and error.
Yeah.
But if it was a really complicated one with a lot of factors here and a lot of factors there, then the California method might actually be useful. Let's see, we got 5 minutes. Good. This is actually great practice. This might be better than if you bring me problems. What's that look like?
Y parentheses Y.
First of all, tell me what it is. When I say what does it look like, what's it called? I want you to remember the name of it just because you will remember it more likely if you know the name of it.
Is it a quadrilateral?
So the difference, because of subtraction, yeah, difference of perfect squares. So what's the answer?
Y. Minus plus.
It's the square root of 100.
10.
In other words, I took the square root of that to get this term, and I took the square root of that to get this term. That's all you're doing when you're factoring difference of perfect squares. What was that one? That was 13, okay. Oh, brother, how can they possibly give you this one? All right, let me give you this one, and I'll show you how they want you to do it. Believe it or not, is this a quadrilateral? Excuse me. Is this a quadratic?
Yes.
No, it isn't.
No.
It's a cubic. Quadratics, by definition, mean the highest degree is 2.
Okay.
Cubics, the highest degree is 3. Now, what you're going to be amazed at is how hard it is to factor cubics. You think quadratics are hard to factor. These are unbelievably difficult. In fact, it was only like 200-300 years ago that they figured out how to factor these. So this is a difficult problem, except sometimes if they fit a certain type, you can do it. Well, what am I looking for? I'm looking for this number's relationship with that to be the same as this relationship with that. And they are. 2 is to 1 as 6 is to 3. Once I discover that, I can solve this by a method they call grouping. And watch what I do. B3, I group those two together.
Okay.
And I group these two together separately. And now I factor each one. What can I factor out of this one?
A B.
A b squared.
B squared.
Looking for a greatest common factor. What's left behind?
2B.
No. Divide b squared into b cubed. That's this term.
B, is it just B?
And then divide 2b squared by b squared to get the other term.
Is it just b?
It's 2.
2.
In other words, 2b squared divided by b squared. The b squareds cancel and you're left with just the 2. Okay? So, that term factored into these two factors. What can I factor out of this?
3b.
Just 3.
Just 3.
Yeah, I can't do a 3b because b doesn't divide into 6. And I can only factor something that divides evenly into both terms. Well, 3 is the only thing that divides evenly into both terms. Now look what we have. We have something that you've probably never seen this done before. That's what makes it kind of strange and yet interesting also. What can I factor out of that expression? I can factor the b minus 2, the whole thing out.
Yeah.
Why? Because I can divide that by b minus 2 and I can divide that by b minus 2. Well, what's left when I do that? When I divide this, yeah, b squared over here. What's left over here? When I divide this term by b minus 2, what do I got left? The term on the right.
3?
Yeah. So look at that. I factored it.
Okay.
And now I could actually solve it. If I had this in an equation, well, my answer is b equals 2 and b squared equals minus 3. And then I could take the square root of both sides to get answers. So there was an example of solving a cubic by grouping. And the problem is, that's a wonderful method, but the problem is it only works on about 1 out of every 100 cubics. Is all I got to do is change this number to a 7 instead of a 6, and it doesn't work anymore. And now I have an enormously difficult problem to solve. But if it happens to fit the grouping definition, then you can do it the way I just solved that. All right, let's wrap it up. And that was a good session tonight, Julian, a very good session. I will talk to you next time, and enjoy your spring break next week.
Okay, thank you.
All right, bye-bye.